So I'm today going to start on a new topic of identity. So identity is expressed using this equal symbol thing, called the identity sign. So that's the identity sign. It looks a lot like the equal sign in arithmetic, like 1 plus 1 equals 2. But it's not the equal sign in arithmetic. It expresses rather the relation of identity. It's not obvious that equality in mathematics is the same as identity. It's the identity sign. This expresses a relation of so-called numerical identity. Numerical identity is a relation that every entity in reality or in the universe bears to itself and only to itself. And it's the relation of being one and the same entity or one and the same thing as. So everything in the universe bears it to itself and only to itself. Everything is what it is and isn't anything else, as G.E. Moore once stated. Everything is what it is and not another thing. So, nevertheless, in logic, you can get these formulas which say that x is identical with y. So there's the formula x is identical with x, which is, given our understandings of how these terms are to be used in a well-formed formula, will always be a true schema. X is identical with y may or may not be true, depending on whether y is x. Right? So if x is the Eiffel Tower and y is the Taj Mahal, then it's not going to be true. But if x is the Eiffel Tower and y is the Eiffel Tower, then it will be true. Everyone with me on this? Right, because in order for the relation to hold between x and y have to be one and the same thing, numerically one and the same thing. So if you have so-called identical twins, they're not numerically identical, so they don't stand in the relation of identity, even though they're often described as identical twins. What's meant by saying they're identical twins seems to be that they have all of their properties identically. That is, the set of x's properties and the set of y's properties are identical, but not that the object x and the object y are identical. That is one and the same object. They'd be two different objects with the same properties, if you could have that. It's very hard to find two things that have exactly one. Like there might be some minor difference between them. Like one has one more hair than the other has, or a bump somewhere. Yeah.
So will we use x equals y in situations where we call one object by two different names?
Yeah.
Like Bruce Wayne equals Batman.
Right. Well, of course, they don't exist, but whatever.
Right, right. Yeah. Just as an example.
Yeah, sure. Cassius Clay and Muhammad Ali.
Yeah. Yeah.
An alias.
Yeah. Okay.
Yeah. Yeah, so you can have true identity statements between a thing and a thing with a different name, provided that one name is an alias. So it may be that I am identical with my body. That may be true. Or I am identical with my brain. Possibly. Seemingly. That may be true, even though you have two different terms there, or it may not be true, right? Maybe I'm not identical with my body. Maybe I'm identical with my mind. And my mind is not identical with my body. Maybe. So those are all highly controversial, disputable metaphysical issues. So we can say for sure that my body is identical with my body, though. Right? That's the X is identical with X case. My body is identical with my body. So we don't have trouble with that one. So knowing the second one, I am identical with my body, is a much greater epistemic achievement than knowing my body is identical with my body, which is essentially a type of tautology.
Could there be a language misnomer if you said, I am my name, William? In other words, in language itself, would you see that as more obscure than identical? If you, in other words, I and my name are one and the same?
Well, you and your name are not one and the same. Maybe what you mean is that I and Professor Rosencrantz co-refer. Is that sort of what you have in mind?
Yeah,
That,
yes.
that this
Yeah.
symbol and this symbol designate the same object?
Right.
Yeah, that you can say.
And I was just wondering, in language itself, does it?
I think you can, I mean, I think they're equivalent.
Okay.
To say that two singular terms co-refer is going to be equivalent to saying that the objects which they designate are identical. Yeah,
That's like the morning star is the evening star thing.
yeah.
Well, is it similar to Hephaestus is Hephaestus?
Is it similar to?
Hephaestus is Hephaestus, like it's like the word is itself, but does it connect? Do words like an identity like inherently connect to something that's physical, or can they connect to something that's just themselves? Like if there's a word that exists, but it doesn't have any connection to something physical, can it still exist?
I'm not sure what you mean. I mean, you can have identity statements between words, too. I mean, you can say the word red is identical with the word red.
Yes, I think that's what I'm asking.
Could you do red is identical to Rohan?
Well,
Would not, well, I guess that wouldn't be the word anymore. That would
it would be a different
yeah.
word. There, I think what you're after is semantically equivalent.
Yes.
But that's not identity.
Okay.
That's a different relation.
Okay.
Though it has some things in common with identity. But more on that later. But right now we're just concerned with identity, so we don't want to drift too far field here. Okay, so these are the ultimate, the real basics of the identity relation. So now we can go to the next step up. Identity is considered to be a relation, primarily. So people speak of the identity relation. So a relation is something which a certain object bears to something. But identity is a unusual relation, or highly specialized relation. Most relations are going to be born by an object to some other object, like the relation of sisterhood or brotherhood, right? It's a relation among different things. Or the relation of being on. The eraser's on the tabletop. So you have two things related, the eraser and the tabletop, which are distinct things. More exactly, the tabletop and the eraser are diverse. So diversity is the opposite relation to identity. So diversity says that X and Y are numerically numerically different. And we write diversity like this. We say X is not identical. Y, X is diverse. So that's diversity. It's the symbol with the slash through it. X is diverse from Y tells us that X and Y are two distinct things. So if you say the mind is diverse from the body, then you're a dualist.
Identity is an unusual relation.
Right, yeah. I'm just checking this swivelly thing here. For some reason it's not communicating properly. All right. At any rate, yes, so what's a little bit unusual about identity, as I said, is that it's a relation that things don't bear to other things.
It just bears it to itself?
Yeah.
Oh, okay. Yeah.
So that makes it what's called a reflexive relation. So reflexive relations are relations that things bear to themselves and not to other things. Technically, it's a relation that something can bear to itself. So there are other relations like that. Congruence in geometry. But congruence can be born to something other than a thing as well. So this eraser is congruent to itself. Congruence means it could theoretically be superimposed on itself geometrically. So it means having the same dimensions, exactly the same dimensions. So one triangle is congruent to another triangle when you can lay one on top of the other and have them fit exactly on top of each other. And of course, every triangle is congruent to itself for that reason. Okay, so identity, like congruence, is reflexive. So identity is reflexive. It's also symmetrical. A symmetrical relation is, so a reflexive relation is where you can say X bears the relation to X. So if you're talking in general, then I guess it's a reflexive relation. You can say X bears that relation to X.
So the identity is reflective?
Yeah, it is reflexive, and there are other reflexive relations.
Oh,
Like-
and then there's another word you use to describe identity?
No, that's yeah, identity is also symmetrical, which is the next. I was just backtracking, I'm sorry. So you also have it's also symmetrical. So symmetrical relation is where if you have X is Y, that implies Y is X in the case of identity. So more generally, X bears R to Y implies that Y bears R to X, which holds for identity. If X is identical with Y, Y must be identical with X, right?
Mm-hmm.
If X is the very same unit as Y, then Y is the very same unit as X, right?
It's like modus tollens or
Well, it's just like what it is. It's, you have that symmetrical relation is going to hold. So it's identity is reflexive, symmetrical, and finally transitive also. A transitive relation is where if you have X bears the relation to Y, and Y bears that relation to Z, then X bears it to Z. It carries through. So in the case of identity, if X is identical with Y and Y is identical with Z, then that means that X is identical with Z. So you might think you could define identity as the relation which is reflexive, symmetrical, and transitive, but that doesn't work, again, because of congruence, which also has all three.
My question is, what's
Yeah, because congruence is also transitive. Like if this triangle can be superimposed on this triangle, which can be superimposed on that triangle, then the first one can be superimposed on the third, which gives you transitivity. And symmetry comes from if X is congruent to Y, then Y is congruent to X. And reflexivity, everything is congruent to itself. So, yeah, so congruence meets the same three criteria. So it'd be nice to have a simple analysis of the identity relation in terms of those three factors, but it doesn't work to single out just identity. So the problem then remains, can we define the relation of identity? Can we define that relation? Or analyze it? We analyze what it is for X to be identical with Y. So that's our next question. Yeah.
Just for me to understand your shorthand better, when you have identity symbols and then you have the identity with the little arrow, is there a difference in the meanings?
Of what?
So you have X equals Y, ampersand, Y equals X, Y equals Z, and then you have this right-hand arrow. Does that just mean change, or what does
That means implies or,
Okay.
yeah.
And that's for transitive?
Yeah.
Yeah.
You have it for symmetry and also for reflexivity. Right. Oh, for reflexivity, we don't need the arrow. It's just like X equals X. For any X. Yeah, so all that's very interesting, but now we get to like, how do you define identity? So, if I can erase this stuff, is that okay? Yeah, so one of the main proposals was made by Leibniz, Gottfried Wilhelm Leibniz, great mathematician and philosopher of the age of reason, great rationalist, metaphysician. He put forward a principle that's known as Leibniz's law. So Leibniz's law says that, at least in a simple initial formulation, just to give the basic idea, Leibniz's law says that X is identical with Y if and only if, which I'm going to abbreviate just by writing IFF, or if and only if. X is identical with Y if and only if X has every property Y has. And what else? Y has every property X has.
Like the identity of indiscernibles.
Hmm?
That's the law of like identity of indiscernibles.
Well, that's a concept. That principle is a consequence of this. This is stronger than that.
Okay.
You said what, the identity of indiscernibles? Is that what you said? Yeah, there's also the indiscernibility of identicals. And this is a conjunction of those two, which we haven't talked about yet. So we start out with this one, and I can analyze it into those two principles in conjunction. This covers both. This implies both of those things. That indiscernible things are identical, and that identical things are indiscernible with respect to properties. So this is saying if two things have the very same, if X and Y, I shouldn't say two things, right? It's always tricky. If X and Y, which may be the same thing or two different things, right? If X and Y have the very same properties, they're identical. And if X and Y are identical, they must have the very same properties. So this is often called Leibniz's law. So you have the indiscernibility of identicals. Which says if X is identical with Y, then X has every property Y has, and Y has every property X has. So it's just an if, not an if and only if. So this says that if X and Y are identical, they must have the same properties as each other. Because they're one, here's the reasoning. If X and Y are one and the same object, literally, right? There's this one thing which we call X and also Y, as you put it earlier, right? If that's the case, then X and Y can't have different properties. They're the same thing. So they'll share all the same properties, being just one thing that has the properties it has. whatever they are.
It is what it is.
Yeah, it is what it is, right, exactly. And that's what it is, right? Whether you call it X or Y,
Right.
yeah. Or whether you refer to it by the variable X or this other variable Y. Since X and Y aren't names, they're variables which happen to refer or pick out these things by hypothesis. Okay? So that's your indiscernibility of identicals. So a lot of people say this is self-evidently true, yet there are others who try to argue against it, believe it or not.
No, when they say self-evident, is that the same as intuition?
No, but things that are self-evident may be known by intuition. Maybe they can be known in other ways,
Okay.
like by the fact that they're self-evident, or by sense perception, or by whatever,
Oh, different-
depending on your theory of
different
like what's.
perception.
Well, just depending on your theory of how you know these, whatever it is that's self-evident.
The object.
No, I'm just saying there are different views in epistemology about what things count as self-evident and also about what modes of access we might use. Intuition's one possibility, but
Could be.
it could be something else.
Cognition.
Could be something, yeah, whatever, something else. Okay, so then you have the identity of indiscernibles. So this says that indiscernible things have to be identical, which is different than saying that identical things have to be indiscernible. This is saying that if X and Y have the same properties, they must be the same thing. So essentially it's saying you can't have perfect resemblance between two different things.
Yeah.
You would just
So
have
these-
two tokens of the same thing.
Well, they're saying you can't have two if they have the very same properties.
Okay.
It's one thing.
So those are internal or external properties that
Uh,
are being
Well,
identical?
depends on, there are different versions of the identity of indiscernibles. Some say in terms of just intrinsic properties, but others say, no, it's true in terms of both intrinsic and the relational properties. But let's get it formulated first before we. So it's going to say, if X has every property Y has and Y has every property X has, then X is identical. See, so the order is flipped here, right? Between the indiscernibility of identicals and the identity of indiscernibles. One starts out by saying if X equals Y, then da 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 da. And the other says if da 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 da, then X equals Y. That's the difference between the two. So the indiscernibility of identicals is trying to make the point that if by hypothesis X and Y are the same object, then all the properties we assign to X, all and only the properties assigned to X can be assigned to Y. Identity of indiscernibles is saying that if you have two objects that are exactly similar in every way, they must be identical. They can't be two different things
Right.
that are. They can't be like identical twins or something.
Right. Yeah.
So it's saying identical twins always like differ in some way.
Right.
Like one has a mole.
One has a bigger suntan.
You know, something. One has one more hair. one more hair that's a little longer than some other hair, or
Always not different.
there's always something different. It's saying there's always something different between two different things.
That
Yeah.
isn't necessarily false, right? Because, well, I can name one difference is.
You mean necessarily true?
No, that's not false. It's not false because.
It's not
if there are-
false. Well, yeah, it doesn't seem false.
No.
Obviously.
I don't know, I was thinking that.
I mean, most things are
But
different, but are they necessarily different if they're two? That's the question.
I would,
And as she brought out, you have to also consider whether they're intrinsic properties only or also relational
Yeah,
properties.
that's what I was interested in.
That's a big deal with this principle, exactly what the scope, what you include under properties. So you get two versions of it, right? The more stringent, the more controversial version says you can't have two things intrinsically alike. And the somewhat less controversial version said they could be intrinsically alike, but then they have to be differently related to something if they are intrinsically alike.
So imagine you have two.
There must be some difference, either intrinsic or relational, for them to be two. The other says there can't be two that are intrinsically exactly alike, like two snowflakes can't be exactly alike. Whereas the other view says, well, maybe they could be exactly alike, but then one would be a different distance from some other, like a tree than the other one. So there would still always be some difference between the two snowflakes, but it would be relational rather than intrinsic to the snowflake.
Could you say then, if
Right, so
God,
there's two versions.
could you say then if God is the most perfect being, you couldn't have two gods?
Well, you can't have two gods according to the definition of God anyway.
Right,
so.
but I'm saying based on the relation of most perfect.
Yeah, it would seem
You couldn't
not.
have two most perfect.
It doesn't seem like you could. No. But
So,
anyway,
With like the or with the indiscernibility of identicals, it seems like identical, something could have, well, like Bruce Wayne, we could not know Bruce Wayne fights crime, but we could know, a Batman fights crime. They're identical, but they have different extrinsic properties, it would seem.
different extrinsic.
Yeah, like in our knowledge of them is different.
Yeah, this isn't talking about knowledge though. These are purely metaphysical or logical claims about what properties the things in fact have, not what we know about them. There's another principle often attributed to Leibniz that deals with what you're talking about, but we'll get to that later. Right now, we're dealing with the hardcore principles here, metaphysical. So both principles have been disputed. So that is, some dispute that identical things would always have the same properties, so that seems weird. And others say that you could have two things that cannot be distinguished by properties. But a lot hinges on what counts as a property. Okay? A lot's going to hinge on what you're allowed to count as a property. So we'll discuss both. Both of these claims. Main simple point is that the original Leibniz's law is the conjunction of these two principles. This original thing, X is identical with Y if and only if they have the same properties as each other, is identity of indiscernibility of identicals in conjunction with the identity of indiscernibles. So it's the assertion of both simultaneously, and that the two together give us an analysis of what identity is, necessary and sufficient conditions for X being identical with Y. All right. Now, there are two more principles that are attributed to McTaggart, who wrote somewhat later than Leibniz in the 19th century. John McTaggart. And these are contrapositives of these principles. Essentially, they're called the diversity of the the principle of the diversity of the dissimilar and the principle of the dissimilarity of the diverse. All right. So the diversity of the dissimilar says that if X and Y differ in their properties, then X is not identical. X is diverse from Y. So so this is the diversity of the dissimilar. So this says dissimilar things have to be diverse. If X and Y differ in their properties, so they're dissimilar, in other words, and they have to be diverse. Like if minds are conscious, but bodies are like these brute, insensitive blobs of matter, then minds and bodies can't, right, be identical.
So this is, would you say that's,
I mean, if you could show that, right?
so this is the negation of Leibniz law? Right?
No, it's the contrapositive.
Contrapositive?
It's the contrapositive of what? What's a contrapositive? That's when you flip the order and negate the antecedent and the consequent.
Okay.
So contrapositive is always equivalent to the original.
Okay.
So this is going to be equivalent to the indiscernibility of identical. And then you have the dissimilarity of the diverse, which is equivalent to the identity of indiscernible. The second principle of the McTaggart's principle of the dissimilarity of the diverse. It says that if X and Y are diverse things, they got to differ in some quality, which is exactly what the identity of indiscernible is. It's equivalent, but stated in the contraposition form.
Did you repeat what the definition of contrapositive is?
Yeah, I will in a second.
Thank you. I know I learned it in logic, but I just forgot the name.
If X is other than Y, if X is diverse from Y, then X and Y differ in their properties. So this rules out having two exactly similar different things.
Two exactly different, so.
Two perfectly resembling things are ruled out if this is true.
Could you even say like isomorphic?
No, they got to be more than isomorphic.
Okay.
They got to be exactly.
Intrinsic and extrinsic properties.
Well, depending on how we understand the original principle. Whether you're arguing that you can't have two things intrinsically exactly alike is one version of the identity of indiscernibles. The other is that you can't have two things that are alike in every way, including relational respects. So this one breaks up into two interpretations. Self, right? But the basic idea is, right, you can't have two things exactly the same. As far as contrapositives, if you have if P then Q, the contrapositive is if not Q then not P. So
Is that definition?
that's definition of a contrapositive. And they're always going to be equivalent.
Yeah.
an example of an identity statement?
I turned it into an equivalent.
Oh, okay.
That was the difference.
Oh, yeah.
Versus identity.
Yeah, yeah. That's what the third thing is. Means if and only if.
Oh, okay.
Yeah. All right, so. Yeah, so what about these principles? Okay, so the indiscernibility of identicals, like anyone up to refuting that? That identical things would share the same properties. That if X is one and the same object as Y. Two main arguments against that. Okay. One is the argument that my friend John and my childhood playmate. So, anyone not okay with my erasing any of this stuff? Not okay? You're not okay with it?
You're good.
I'm good. All right. No one objects. I have unanimous consent. Hmm? All right, so premise one, John is identical with my childhood playmate.
Okay.
Suppose it's true. Two, my childhood playmate was 3 feet tall and had no facial hair. Whatever. Because he was just 3 years old. Okay, 3, John is 6 feet tall and has a beard. Okay. Okay. So, therefore, John and my childhood playmate have different properties. So this would come from 2 and 3. Because John, right, 6 feet tall and has a beard, and my childhood playmate was 3 feet tall and beardless, right? No facial hair. So from those two premises, we get that John and my childhood playmate have different properties, and then we get from 4 and 1 that the principle that identical things are indiscernible is false.
False.
Yeah. The indiscernibility of identicals. Is false, which comes from 1, which says John is my childhood, identical with my childhood playmate, together with 4. That they have different properties. So that's the John and my childhood playmate argument against this principle that identicals have to be indiscernible, have the same properties.
So time couldn't be considered, timeline could not be considered a separate property.
Well,
Since John.
what
and-
premise are we going to reject here? So the best way to approach these kinds of things is, are all the premises true, and does the conclusion logically follow? So if the conclusions logically follow, then, right, so there's two ways to critique an argument. One is to show that the reasoning is defective. The other is to question a premise. So you were saying that you could identify a dubious premise here?
Yeah, premise one.
Premise one.
Yeah, it's
Sit
like
there.
the time.
Well, that's one way to go. So why is that false, that John is identical with my child?
I mean, it seems that they're not identical, but they have, well, I don't know, I can't do it without presupposing, the idea that the fact that they have different properties makes them diverse. So, but yeah, it seems like premise one is the one that I would have to oppose.
So you'd be saying that with Heraclitus, that, right, things are constantly changing and nothing maintains its identity. Nothing endures or persists through time.
Maybe not.
It seems like that's where we're logically going to have to go if we go that route.
Yeah.
Because if John is not identical with the childhood playmate, what that exists now is identical with what existed in the past. Some have held that everything we observe is made up out of innumerable evanescent slices of being, so that the you that exists at one moment and the you that exists at a moment after that are two different yous. And not the same substance at all. Yeah, so that would be one way out, right? I mean, if we say that nothing can endure through time, then the principle is saved, right? So, I mean, that will get us out of the argument. But do we want to go there and say that from one moment to the next we go out of existence and a new person is born?
You can, the accidental essential property distinction can be drawn, like that there are properties that can differ that don't make a different identity, like height and beardedness.
Right, so, but then we're not rejecting premise one, so we have to find some other flaw in the argument, right? So, let's see, 2 and 1 seems true, right? If we say what you just said, anyway. I mean, I do remember playing with John when I was a little kid. It seems like I remember that I played with him, not some other person. So, and 2 and 3 are true, right?
No.
John's 6 feet tall. My childhood playmate was 3 feet tall. All those are true.
2 is the flaw, though, right?
I don't see that there is a flaw because they account for time and passage.
Just because my childhood playmate was 3 feet tall, it does not mean that that is still 3 feet tall to this day.
No, he's not.
Yeah, no. In fact, 6 feet tall.
Right, if you believe.
So, but that doesn't mean that John is not identical to my childhood playmate. It just means that my childhood playmate grows. So if we added that as a premise, my childhood playmate was 3 feet tall. My childhood playmate grows with the passage of time. My childhood playmate is now 6 feet tall.
Yeah, so what's wrong here? What inference is...
You need to explicitly say that there's a passage of time.
It infers that.
Well, look, we have 2 inferences in this argument, right?
That's time's passed.
We have the inference of 4 from 2 and 3.
Yeah.
Okay. So there's that. So we could question that, right?
Yeah.
You can question that. The other inference is that because they have different properties and they're identical, that the indiscernibility of identicals is false. So there are two steps whose deductive validity could be disputed, even if you can't dispute the truth of any of the premises. But if we do go after a premise, like you say, it would be one. But then we seem to be stuck with pretty skeptical consequences about personal identity, like that we don't last very long, which we're not eager to accept. All right. There's a kind of continuity that we believe gives us evidence of true identity.
Continuity gives us true evidence of identity.
I said there's a kind of continuity that we experience that gives us evidence of our identity over time, it seems. Well, and we all believe that we endure through time. And I think we do it based on memory largely, and that sense of continuity that memory gives us. If that makes sense.
Yeah.
Yeah. So maybe what we need to do is put a time indicator in Leibniz's principle to say that if x is identical with y at time t, then at time t, x has every property y has, and y has every property x has. So that would do what you were. And then it wouldn't follow that the identity of indiscernibles is false.
Right.
Because at a single time, as you pointed out, they don't have different properties.
Right.
You'd have to show that at one and the same time then to refute the identity of indiscernibles as newly formulated with a time indice variable in it. You'd have to show that at a single time, something that's identical to something, that the first thing has a property at that time that the second thing referred to doesn't have at that time. That's impossible. You can't show that at one and the same time John is both 3 feet tall.
In 6 feet.
Yeah.
Right.
So the principle would then say if x is identical to y at t, right? Right. Then at t, x has every property y has, and y has every property x has. And at time t, right, x has every property y has at t, and so on.
And is t the same t? Or
Yeah, the same t. Yeah.
Okay, so it's like time one.
Yeah, whatever time you're talking about, like now or whatever. Yeah, for any time t, right? For any time t, if x is identical with y at that time, right? Then at that time, x has every property y has at that time, and so on. And y has every property x has at that time. They have the same properties at that time. I'll just make it shorter. X and y have the same properties at that time.
How would you frame it for the dualist? The dualist wouldn't take time into the equation, would he? If you're actually two separate things from your body.
Yeah, but that doesn't come up here. Here we're talking about the case where they are the same.
Honestly,
The skeptic is questioning that. He's saying even when they are identical, they might be
they
different.
Still might be different, yes.
One might have a beard and one might be
Right.
beardless, but not at the same time they can't be. So this tells us that at a given time, when x and y are identical at that time, x and y share the same property, same properties. So that stands up. So it looks like we either go that way or say that nothing endures through time. Right? Which is the other. So,
Except for universals, right?
uh,
If that were an argument you were to adopt.
This wouldn't arise with universal, so you're right, right? We wouldn't have to worry about that.
Yes.
They're not in time. Or at least they don't change.
Go under intrinsic change, though, right?
They don't undergo intrinsic change.
Aristotle's do, because they can come in and out of time.
Oh, Aristotle.
Yeah.
Aristotle's different.
Yeah, but they don't change qualitatively, they just go out of existence.
The qualities don't change, they come out in and out of existence.
Yeah. Right. Yeah, so, right, so with two remedies here, but the one that seems less damaging to our common sense belief system at any rate is to specify the principle of the indiscernibility of identicals to a given time. So you could say John has the property of now being 6 feet tall and the property of having been 3 feet tall earlier, right? And so if you express the properties that way, they have the same properties also. Right? Both John and my childhood playmate now have the property of, in the past, having been short, that in the present, being tall, and in the past, having been beardless, and presently, having a beard, and so on, right? They have exactly the same properties now. Or at any other time you pick, at that time. Make sense? So that's how we get out of this thing. However, there's another challenge that has nothing to do with time.
I'm just trying to guess if those states.
Challenge to the same principle of the indiscernibility of identicals. Okay, so for this one, we start out with the premise that the morning star is identical with the evening star. And then our second premise tells us that Smith believes that the morning star is visible in the morning. Smith is just some hypothetical guy. I'll just abbreviate that by saying AM visible. Because I'm running out of room. Premise 3, Smith does not believe, though, that the evening star is AM visible. He thinks it's only PM visible. Okay? Does not believe that the evening star is AM visible because he thinks it's only PM visible because it's the evening star. He doesn't make any connection between the evening and morning stars. So now we derive 4 from 2. And 4 says the morning star is believed by Smith to be AM visible. So that comes from 2. Well, from 1 and 2. 1 tells us that there is a morning star because it's identical with the evening star, and anything that's identical with something exists. And 2 tells us that he believes that the morning star is AM visible, so now it seems that the morning star is believed by Smith, this object out there, the morning star is believed by Smith to be AM visible. Okay. 5, the evening star is not believed by Smith to be AM visible, from 3, according to this argument. Did I say morning? The evening star is not believed by Smith to be AM visible. Okay. So now we get 6. The morning star has a property the evening star doesn't have, namely the property of being believed by Smith to be visible in the morning. But that's bad for Leibniz's law because the morning star is identical with the evening star. So now it seems that like psychological properties could screw up, psychological relational properties could screw up the indiscernibility of identicals. So finish with that. The morning star has a property that the evening star lacks, namely the property of being believed by Smith to be AM visible. Okay, and then from 6 and 1 we get that we get that the indiscernibility of identicals is false. 6 and 1. Because you can have identical things, the morning star and evening star, with different properties. One is believed by Smith to be visible in the morning star, but the evening star is not believed by Smith to be visible in the morning. So, yeah, the indiscernibility of identicals. Is wrong. False. From 1 and 6. Yeah.
It seems like this argument relies heavily on the assertion that being believed by Smith is in fact a property.
It does.
Yeah. So if we can prove that being...
But it is a property.
Is it?
Yeah. It's a relational property.
Yeah.
What's that word after of for 27?
Identicals. Indiscernibility of identicals.
We're also getting a lot of baggage out of the word believe.
Yeah.
Smith could believe anything about the star.
Yeah, but like I said, we got to learn to analyze these arguments in terms of the premises.
Right.
And 2 things: are they true And do the logical inferences validly follow? Okay, so, or not. Okay, so 1 is fine, right?
Mm-hmm.
Yeah. And 2,
It's fine.
and so is 3. These just report empirical facts, right? Smith does not believe that the evening star is AM visible. Well, he doesn't believe that, right? He thinks that's a separate, he has no clue that the evening star and the morning star are identical, right?
Right.
So he has no clue. He's clueless. Okay, so 1 through 3 are fine. So then, can we get from 1 and 2 that the morning star is believed by Smith to be AM visible? Seems like it. Okay, so let's, right, so it seems like Smith bears this relation to the morning star of thinking that it is AM visible. Why? Because he sees it, right? It's actually there. It's not an illusion or anything.
Right.
So it stands in that relation to him. His psychological attitude of belief or attribution of AM visibility is attributed to that object via his sense perception of the object. It's a relational property of the morning star has in relation to him. Okay. What about 5, though? Does 5 follow from 3? 3 says Smith does not believe that the evening star is AM visible, okay? And he doesn't believe that. Does it follow from that that the evening star is not believed by Smith to be AM visible? And you can argue that it doesn't follow, because if you're talking about a relational property, since the morning star is identical to the evening star, when the morning star is believed by him to be AM visible, so is the evening star believed by him to be AM visible, unbeknownst to him, however.
Mm-hmm.
And this is a peculiarity of de re belief that's focused on a thing, is that often we don't know. Like if we don't know that Muhammad Ali is Cassius Clay, when we're introduced to Cassius Clay, we don't know that we're being introduced to Muhammad Ali, so we don't believe that he's Muhammad Ali, but he still is.
Yeah.
And Muhammad Ali is still believed by us to be the person that we're meeting, even though we don't believe that the person we're meeting is Muhammad Ali. Remember the difference between the de dicto versus de re? So in de dicto belief, you believe a proposition, like that the morning star is visible in the morning, or that the evening star is visible in the morning, which this guy doesn't believe, that second one.
Right.
Yeah. But when the morning star is believed by you, that just means that this object out there is the object of your belief. And that object is the object of your belief under any description it truly falls under. So 5 can be rejected, and it doesn't follow from 3. So the argument collapses for that reason. So we can still hold on to the identity of, we can still hold on to the indiscernibility of identicals, that identical things have the same properties. This doesn't disprove that. Okay. All right, now Leibniz had another principle, though, called the principle of unqualified substitution. Which has to do with singular terms, like names and other terms that refer to a single thing. The principle of unqualified substitution says that for any singular term, any singular terms, T1 and T prime and T double prime, if T prime and T double prime co-refer, That is, they pick out the very same object, pick out the identical object, like Donald Trump and the President of the United States, right? Do terms like that. Then T prime and T double prime can be substituted for each other in any sentences in which they occur, salva veritate, which means without affecting the truth values of those statements. So they can be substituted for each other in any statements in which they occur, preserving truth, salva veritate, without affecting the truth value. So if you have a statement like, Trump is married to Melania, right? Donald is married to Melania, then a co-referring statement, the President of the United States is married to Melania, should have the same truth value as Trump is married to Melania. That's the essence of it. And if the sentence is false, same thing. Trump is President of Ecuador, and Melania's husband is the President of Ecuador, will have the same truth value as Trump is the President of Ecuador, because Melania's husband and Trump co-refer. And so if one statement's false, the other statement will be false. So the truth value is always preserved when you substitute co-referring singular terms for one another in statements, according to this principle. Right? This thing is not true. So we'll discuss that next time. See you all then. This principle doesn't hold up. There are many counterexamples to it, and they're related to the evening star, morning star kind of cases. But here we're talking about language rather than about things. All right, so we'll call it quits for today.